From Iron Man to our very own Rajnikanth, don't robots seem super cool ... and almost magical? Not just that, think about one machine performing tasks that would require 44,000 humans. Well, this is what mechanical engineers do, and this is the power of mechanical engineering, to make the unbelievable a reality. Life has become much more exciting and easy because of mechanical engineers, and that is why it is called the mother of all engineering. Mechanical engineers play an important role across every facet of our life: automotive, aerospace, biotechnology, computer and electronics, automation, and manufacturing industries. They design, develop, build, and test all sorts of mechanical devices, tools, engines, and machines. Mechanical engineers design and manufacture everything from the tiniest part to the largest. Look at the dentist's drill and a bearing inside. You name the device, and a mechanical engineer is behind it: transmissions, aircraft and vehicle engines, control systems, smart devices, disk drives, printers, semiconductor tools, futuristic sensors, wind turbines, fuel cells, compressors, machine tools, and even robots. One such shining example of what you will learn at DSI can be taken from the Venus flytrap. You will hear more inspiring stories when you sign up to join the engineering stream at the DSI colleges. The DSI campus has produced thousands of mechanical engineering professionals who can be found occupying corner offices in large MNCs, government, industry, as well as premier academic institutions across the world. Very few programs give you an education that combines information with application, and that is the power of mechanical engineering at DSI. Empower your mind and power your life. Talk to a DSEN before you pick your college, and do drop by for a visit to our facilities. We would love to see you soon.
Right. Good morning, everyone. Hello, and welcome to this webinar on mechanical engineering in the digital age. This is a part of the career counseling series brought to you by the Hindu Group, today in collaboration with the Dayananda Sagar institutions. I'm Anukripa, and I'll be your moderator for today. Now, when I say mechanical engineer, who is the first person that pops into your head? Who's the most popular mechanical engineer that you can think of? Are you struggling to think of someone? I have someone in mind. I'll give you a clue. They actually talked about him even in the intro video, if you managed to catch it. He is He is a character in one of the biggest series of blockbuster movies in the world. I'll give you another hint. It's the Marvel series. Millions of people have watched films about this character. He is a superhero. But unlike other heroes who have magical powers, he has to build his own power suit. He works with robotics, automation, manufacturing, aerodynamics, and design. That's right, I'm talking about Iron Man, if that's who you thought of, also known as Tony Stark in the Marvel Universe. Fun fact, Tony Stark in the Marvel Cinematic Universe is also a graduate of mechanical engineering. While we think of Iron Man as a superhero, he makes us clap, he makes us hoot when he's flying around. Think of him also as an engineer, specifically a mechanical engineer. There's some truly fantastic engineering shown to us in our big action movies, like Iron Man. But here's something to think about. Some of that engineering isn't just the stuff of movies and comics anymore. Mechanical engineering as it exists right now in the digital age is way more exciting. Mechanical engineers are working on cool projects that are changing lives everywhere and have even changed your life, even if you've not thought about it. In fact, our panelists today, all esteemed mechanical engineers in their own right, have all worked on projects that sound like they could be part of a Marvel movie. They sound like maybe Tony Stark could have been a project partner with them. Dr. Hasibuddin MR has prototyped a remote-controlled stair-climbing wheelchair. He is an expert in production engineering, systems technology, and nanomaterials. He is also an associate professor at the Department of Mechanical Engineering at Dayananda Sagar College of Engineering, Bangalore. We also have his colleague with us from Dayananda Sagar College of Engineering, Professor Anand Badigar. Professor Anand has worked on a design of a self-balancing vehicle and also on the fabrication of a biodegradable solid waste converter. What did I tell you about all of those cool projects, right? Professor Anand's expertise is in structural, thermal, and fatigue analysis of machine components. Both professors will throw light on the work and study aspects of mechanical engineering soon, but we'll first hear from Dr. Dinakaran. Dr. Dinakaran led a team which designed a robot, Sevili, which can serve food, medicines, and is being used in isolation wards in a government hospital during COVID time. He is a professor in the Department of Mechatronics Engineering at Hindustan Institute of Technology and Science. He also leads the Center for Automation and Robotics. His work is truly interdisciplinary, as you will find all the work of mechanical engineers are, with application in manufacturing, automation, transportation, energy, and materials. All three of our panelists today are working on some truly ingenious projects with real life benefits for ordinary people and their lives. They also all have a passion for teaching and guiding the next generation of mechanical engineers, which could be those of you who are watching right now. So I'd like to thank Dr. Hasibuddin, Professor Anand, and Dr. Dinakaran for their time in being here. Audience, please feel free to use the Q&A section to ask them questions. As we go through this section, we will address as many questions as we can through the discussion over the next hour. Dr. Dinakaran, could you start us off by telling us where mechanical engineering is right now? What does it look like in 2022?
Yeah, so thank you, Anakraba, for giving a nice introduction. And I would like to thank for the Dayananda Sagar institutions, the Hindu, for giving this opportunity to meet all of you. Before starting my presentation, I would like to congratulate and appreciate all the students who have shown interest in this program. And my presentation will be on mechanical engineering in digital era, focusing towards robotics, automation, and mechatronic systems. There are three different verticals in the mechanical engineering. In the introduction video also, they mentioned many applications of these three different domains. One is the thermal engineering, design engineering, and manufacturing engineering. Manufacturing engineering has different verticals, in which robotics is one of the verticals. That is what I'm going to present to you. What are the various fields in the robotics to learn, and how it is evolving over a period of time, and what is the scope for mechanical engineers in this domain. So once again, I would like to thank all of you. I start my presentation with the introduction to the industrial revolution for the last 4 or 5 decades. If you see the industrial revolution, the first revolution starts with mechanization, water power, and steam power. Then the second is focusing on the mass production and assembly lines. Because of the introduction of electricity, many of the actuators are adapted in industries. The third industrial revolution focused on the automation sector. There the many industrial robots are introduced for material handling and processing of operations. The introduction of a computer brings many colors in the factory automation. The last one is the fourth generation, that means fourth industrial revolution, that is focused towards cyber physical system. That is what we call it as digital era. So this cyber physical system uses the data, networking, big data, artificial intelligence, robot to robot communication, robot to man communication, man to machine communication, and enable the overall industry to improve the productivity services to the customers. And if you see the various verticals of mechanical engineering, how it is evolved over a period of time, how it is blending itself with the different domains and bringing different flavors in the various sectors. If you see the mechanical engineering, when it is started, the complete IC engine is with 100% mechanical setup. But now the EV vehicles, we know even in the IC engines, we have EMS systems and many electronic systems, entertainment systems in the automotives. That shows that mechanical engineering is combined with the electrical systems for producing EV vehicles. The battery systems are used in that, and then they are coupled with the electronic systems and communication to make the system as smart system. And the second one, if you take, you could see in the streets, there are many lathe machines, welding machines, drilling machines used by many of the workers. They are conventional machines. When the control systems are introduced in the field, then controls and automation makes the machine as very effective, and CNC machines are introduced in the market. In 1980s, mechanical engineers studied about the conventional machine tools, and in 90s and 2000 they studied about CNC machines, and now we are studying about the smart machines. And you could see the improvements in the smart homes. So previously civil engineering is just civil engineering, but now the building consists of 40 to 50% of electronics that is related to elevator system, then the escalator system, lighting, surveillance, security, and many more electronics into that. Mechanical engineers are more suitable for such kind of works in the civil engineering. So that is why the mechanical engineering, the piping designs, structural, everything is combined with the electronics to bring smart homes to the customers. So when the technology level is increasing step by step, and you can see the system level is moving from mechanical engineering to mechatronic systems, mechatronic system to the smart system to the IoT based system. We are all talking about Internet of Things in the sense communication between the devices through the network, through the data transfer. Thereby, we are taking the advantages of linking all the systems in one umbrella. So that is what we call it as cloud-based systems. So when we are talking about the cloud-based system, the pure mechanical automotive systems or moved to the EV vehicles, and now the EV vehicles are moving towards the driverless vehicles or driverless cars. We know very well about the Google car that is introduced by Google, where there is no driver, automatically drives. So much of big data, artificial intelligence, and data science are built in the mechanical system to make the system as a cyber physical system and to make the system as a smart system. So that is the journey of mechanical engineering for the past 4 or 5 decades. And it is moving from the very conventional mechanical engineering systems to the very modern engineering systems. You can see how the manufacturing is shifting from the conventional to the manufacturing automation 4.0. We are all talking about industry 4.0. That is what we are telling here as mechanical engineering digital era. See, in the manufacturing 4.0, there are many systems that is focused on the automation, smart automation, HMI, human machine interaction. Previously, we have a keyboard, mouse to communicate with the devices. Now we have digital screens. Then now the same thing is moving towards virtual reality, augmented reality to communicate with machines. Many of the smart sensors, monitoring tools are present in the market. Control systems, mobile robots are introduced in the market. Say, in the industrial revolution 3, all the robots inside the factory to automate, but now the robots are coming out from the factory. Initially in the video, they showed the Chitty robot. In the similar way, Amazon has introduced drone delivery, and then robots for delivering the goods to the communities. So these are the main things that are coming to the market that is making the mechanical systems into the modern mechanical systems. See, when we studied in 1990s, 95, during that time, we studied engineering drawing. After that, the CAD drawings are introduced, computer-assisted drawings are introduced, computer-aided drafting is introduced. Thereby, many software packages students learned, and now the full industry is utilizing the CAD softwares. No more manual drawings are available. Now the same thing is marching towards reverse engineering. You have a product, 3D scan it, automatically it will generate the CAD drawings for you. So that is the next stage of the drafting. And you could see the machine tools. Previously, it was conventional machine tool, manually operated, and then it is moved towards computer numerically controlled machines. Now the next stage is 3D printing. Instead of subtraction, addition-based method is 3D prototyping or 3D printing, we call it as. Then in the measurements, we studied the mechanical pressure gauges, pneumatic gauges previously, but now all are studying about the real-time data acquisition systems. And then now it is moving towards IoT-based monitoring systems, cloud-based monitoring system. Data is communicated to the server, from the server to the cloud, from the cloud to the small mobile app, you could visualize everything. Then from the computer-aided manufacturing to the computer-integrated manufacturing. Computer-aided manufacturing focuses on factory automation. Computer-integrated manufacturing focuses on factory automation and business activities. Now in the digital manufacturing era, it integrates all the activities, including the service, customer feedback, everything into the simple one package that brings a lot of advantages to the industry in the design, manufacturing, and business point of view. And you could see these are the major trends in the automotive systems, in the automation, starting from industrial IoT. The architecture of the automation is completely reorganized. Previously, it is a system-based, but it is the holistic level of automation done throughout the factory, edge devices for monitoring, and then portable applications and the mobile apps. The whole industry is controlled through a small mobile app. Intelligent control devices are available, collaborative and affordable robots. Previously, we used industrial robots. Now we work with the collaborative and affordable robots, low-cost robots, and integration of AR, that means virtual reality, augmented reality into the physical world for the simulation and to do some remote manipulated activities. And then in a survey, there are core areas identified in the manufacturing and mechanical engineering that is going to lead the world. That is advanced materials and additive manufacturing. If you take advanced material, from the space to the marine applications, from the manufacturing to the medical applications, Everywhere, this materials engineers are required. Additive manufacturing is 3D printing, 3D prototyping application, modeling, simulation, visualization, and immersion, which means that is related to design. And then Internet of Things, robotics, artificial intelligence, big data, cybersecurity. These are the areas which are going to lead the world, in which you can see first two domains are the very core areas that is focused towards mechanical engineering. And then next three areas that accommodates these three areas. That means the industrial IoT, robotics, and artificial systems now comes a part of the mechanical engineering systems. So out of 7 areas, mechanical engineering covers 5 areas mainly. In fact, if you like to study on the big data and the cybersecurity and many more software things also, it opens avenues for you through different avenues. Particularly, I'm taking only one domain, the robots. They are used in the industrial application, starting from the part placement, handling, spray painting, metal cutting, assembly, inspection operations. And now they are moving towards different applications like home assistance, warehouse. In the Amazon warehouse, they are using robots for logistics application, and then companion robots to talk with the patients, elderly people, and to play with children. And space applications, Mars robot challenge, you know very well. And then many of the medical applications like rehabilitation, assistive devices, surgical applications. And after COVID-19 scenario, the robots are introduced in different fields like UV sterilization robots for then retail industry or managed by the robot. Banking sector, they need a receptionist robot so that you could avoid man-to-man contact, human-to-human contact. Then the hospitality industry, the hotels, the robots are helping others. Delivery robots, already I pointed out. So other than this, there are robots applied in the health sector, aeronautical application, nuclear application, underwater surveying application, building application like for surveillance and guard duty, firefighting robots, agriculture, construction, many more places the robots are used. We are all thinking that Japanese or Americans are introducing these technologies in their country. No, it is in our doorstep. Just I would like to show 2 clips of the articles that are published in the Hindu. One is the robots adapted in the Mysuru. Okay, in 2022, in February, that article is published, how the robots are used for restaurants. In 2017, the another article that tells about the robots are used in the restaurant at Chennai. This shows that robots are not somewhere, it is in our doorstep. That also tells you that there are so many opportunities in the field, and mechanical engineering is backbone for such activities. And I could say we developed some of the robots for different applications. The first one, as mentioned by the moderator, you could see many of the robots are deployed in the hospitals for supplying the food and medication. Pipeline inspection robots are developed, wall climbing robots are developed, companion robots to interact with the elderly patients are developed, concrete inspection robots are developed for the ultrasonic inspection of building structures, wall climbing robots are developed for pipeline inspection of external surfaces for leakages and corrosion. This shows the robots covers multiple areas, and so many opportunities are building up throughout the years and the years to come. And then in summary, we could know now the mechanical engineering is shifting from the conventional aspects to the modern mechanical engineering aspects. It is no more a conventional department. It is a very modern department. That is what I would like to say to you. Number 2, it is not a standalone mechanical concept. It is linked with electronics and programming. It is something interdisciplinary department which covers many of the domain and widens the aspects. Number 3, it is covering the futuristic technologies like robotics and artificial intelligence. And then it widens the scope in the advanced materials and additive manufacturing. You have a tremendous scope in the simulation, design, and testing field. No one can replace mechanical engineers in this field. Design means it's pure related to the mechanical engineers. And then the main thing I would like to tell to you is, suppose if you are interested in IT services, but you would like to learn mechanical engineering. Say you are learning mechanical engineering and then you would like to go for IT industry. Is that right place for me? Yes, it is right, because IT industries takes BTech or BE engineering students. They are not asking for any department. Something you should learn some programming or coding, that's all. Even many of the industries, they take and train you. So it accommodates the IT services also. When you are comparing with the circuit branches or other branches, they have its own uniqueness. And this mechanical engineering has its uniqueness that it accommodates the widening opportunities in this field. It opens up new avenues to you. So once again, I would like to congratulate all of you. I hope I could meet you during question and answer session. Thanks for the given opportunity. All the best for your career. Thank you.
Thank you so much, sir. I just have a quick follow-up question. You touched a little bit on this already, but could you elaborate a little bit more about the difference between mechatronics and mechanical engineering? That was one of the questions that came up. And just as a follow-up to that, if there is a mechanical engineering student who says, okay, I also have an interest in IT, I also have an interest in software, what kind of programs, what kind of courses, or what kind of software tools should they brush up on? Is it good for them to include in their courses? Things like that. If you could answer those two things, that would be helpful.
Yeah. So mechanical and mechatronics, actually this mechatronics is a subset of mechanical engineering. Suppose if any student is very focused, he would like to learn only the artificial intelligence, robotics, and automation. As I told you, there are 3 verticals in the mechanical engineering. But if any student is wish to work in one particular vertical, that is robotics, automation, mechatronics system, if he is interested in that, the mechatronics would be the great destination for him. Suppose any student interested in all 3 domains, some wider thing he would like to study, yes, of course, mechanical engineering is the good for him. That is the first question. Second question, you asked about the programming. See, all the platforms has its own languages and programming methods. Say, if they know the C, C++, and Python, that is sufficient. All other things are built on that. Even then, say, if it is robotics, there are different packages, programming languages. ROS is one of the platforms. If they know the basic language, the C, C++, and Python, definitely they can build all other things on it, and they can flourish in any type of IT services.
Thank you, sir. Thank you so much. Dr. Hasibuddin, if I can bring the discussion to you, could you tell us a little bit more about what kind of disruptive technologies are coming up in the mechanical engineering field? And also further to that, if you could talk a little bit more about the curriculum part of mechanical engineering from the student perspective, from the job opportunity perspective.
Thank you, Ms. Anukripya. I'll be discussing or throwing light on the challenges that the mechanical engineers are going to face in the future, and to counter it, what steps can be taken. I'm sharing my screen. I think Ms. Anukripya has already introduced me. My name is Dr. Hasibuddin, Associate Professor in the Department of Mechanical Engineering, Nano Technology of Engineering. In the past few years, many businesses have shifted their operations to virtual platforms, mainly due to the pandemic. Also, there are a lot of advancements happening, and the technology integration has brought a digital revolution in many industries. This has forced to have an interdependent relationship within various sectors of engineering. Also, there has been revolutionary industry changes coupled with there is decline in opportunities in the last 2 years due to the pandemic worldwide. And the employers are now looking for younger work professionals who can possess not only good technical competency, but also they should have problem solving and analytical skills. Also, what they are looking for is good communication skills and ability to work in teams. And the mechanical engineering, though it has been considered as a core branch along with other other engineering fields like civil, chemical, and industrial engineering, has been majorly affected because of the pandemic. And there are a lot of challenges ahead. Though there are challenges in the digital era, it also offers great opportunities for mechanical engineers. So I will throw some light on what are the disruptive technologies that has affected mechanical engineering. Already, my colleague, Dr. Dinakaran has spoken about Industry 4.0 in his presentation. Industry 4.0, it is nothing but it is integration of various digital processes, including Internet of Things, robotics, and automation. Also, additive manufacturing, everything is included. So mechanical engineering engineers need to redesign processes and operations to accommodate these new advances. And Industry 4.0 is definitely going to impact how the products are designed for increasingly smart manufacturing facilities. And one more disruptive technology that has affected mechanical engineering is Internet of Things. I think we all know what Internet of Things is, and it can be included as a part of mechanical engineering curriculum. So it is a system in which various computing devices are interrelated with each other, along with the digital and mechanical machines. Also, the people, that is the engineers, and the objects that are having some identifications can be connected together. So it can transfer data over a network without requirement of any human interference. And one more that is a new latest topic. I think already some universities have included in the curriculum is the nanotechnology. As the sizes of components, you take any component, electronic goods, the size is shrinking day by day. So nanotechnology, it converts the matter into molecular or atomic or supermolecular levels. And nanotechnology helps in making new devices and materials with a huge number of applications. So nanotechnology is a thing that is having a future that is related with mechanical engineering. And one more disruptive technology is the 3D printing. 3D printing technology, there is a lot of scope for 3D printing that is especially in the mechanical domain. Already there is a lot of talk about 4D printing. 4D printing is, I see a lot of articles, many people are writing about 4D printing, that is 4D printing of biomaterials, bioprinting. Already there is a shift towards 4D printing, but still we are way behind, because most of the universities across India or abroad also, they have not made 3D printing mandatory in the curriculum. So the techniques like 3D printing, 4D printing is still in the early phase of development and research. It is done through computer program deposition in a new layer to create a four-dimensional object. So this is also going to have a lot of impact on the mechanical engineers of the future. And one more important aspect is the now we are hearing a lot about electric vehicles and hybrid vehicle technology that uses energy stored in batteries, which can be charged through regenerative braking and also an IC engine. So together, these features result in fuel economy without sacrificing the performance of any vehicle. So hybrid vehicle technology also is going to play a huge part, and it need to be incorporated in the curriculum. And one more aspect that is having a huge, there is a large future is sustainable or green manufacturing. So minimizing wastages in any industry or any domain is it is what required, and it is minimizing the wastage and reducing the negative impact on the environment has to be focused on. It may involve adopting new practices that may influence the process of design, product design, and operational principles also may have to be redesigned. So hence engineers find a viable operation in this as a career choice. There is a lot of scope for green manufacturing, and also I think it has to be taught in universities across. And how we can accommodate these changes. I think it is time that most of the institutions and universities can bring in some changes in the curriculum. So to accommodate these changes, the topics, or we can say courses on IoT for manufacturing can be made as an integral part of mechanical engineering. Also, the courses such as machine learning, hybrid vehicle technology, digital manufacturing. There is a lot of talk about digital manufacturing, how it is going to impact the future mechanical engineering processes. A lot of articles are coming. I think already Mechatronics and MEMS, most of the universities have made it a part of the curriculum. 3D printing technology, all these things need to be included as part of the curriculum. So IoT has a great impact, and it allows manufacturing businesses to plan, control, integrate, and also analyze the various processes in a better manner to create a network of connected machines. So the application, that is mechanical application, that can be linked with IoT and can be included as part of the curriculum. So to add to this, also I think the university should include laboratory sessions or laboratories based on 3D printing. Already some of the universities are doing it, but I don't think as a whole across the country we have seen many universities including 3D printing as part of the curriculum. Most important thing is there may be theory sessions that are included, but none of the I don't think most of the engineering colleges have brought in a laboratory on 3D printing. So the focus has been on project-based learning. So nowadays there's a lot of talk about that is national education policy, and how the projects can be integrated with each of the courses. And a lot of credits have been, a chunk of credits have been given for project work. Usually in engineering curriculum, there is a project in the final year. To make the students learn in a better way, it will be appropriate to integrate a mini project every year. Every first year itself, the student should be they should be used to working on live projects, and internship in the industry also need to be focused on. So in the future, the curriculum it has to take care of the disruptive technologies that may cause disruption, and to make the engineers industry ready. Some points what we need to focus on are the internships at industry, regular industrial visits to nearby industries, major manufacturing facilities, activity-based learning, workshops and webinars, and interactive sessions with industry experts. This is what that need to be incorporated in the curriculum. And I should, I think there's a lot of work going on under national education policy to integrate all this into the curriculum. So that is what I think the curriculum should focus on from now on. So I will end my talk here, and Ms. Anukrupya.
Yeah, thank you, Dr. Hasibuddin. I think one thing that has come out very clearly from two panelists that we've heard is that the industry has changed a lot. It has become more interdisciplinary. There is no longer that just core mechanical engineering aspect of it. Mechanical engineers are working on multiple things. It's become very interdisciplinary, and like Dr. Hasibuddin just shared, the curriculum in institutions, the curriculum in colleges are also changing to reflect that and rise to the challenges that the changes that are happening in mechanical engineering. So keeping that in mind, I'll now take the discussion to Professor Anand. We know that the industry is changing. We know that the kind of changes that have to happen in colleges, in institutions, in the curriculum. Could you talk to us a little bit about what are the what are the job opportunities available for mechanical engineering graduates, whether it's in the government, it could be research, it could be IT related, core, whatever it is. What are the job opportunities? What is the scope for a mechanical engineer who finishes their degree nowadays?
Thank you, Ms. Anukripa. So as both the experts have spoke upon, different fields and with respect to the curriculum, at the end of the graduation, all we'll be looking at is where I can get a perfect tailor-made job for us. So that is what the question that lingers in everybody's mind at the end of their courses. So I'd like to just throw upon a light on the opportunities and domains where mechanical engineers can perfectly fit into. So I'll just share my screen. Okay, I hope it's visible. So I'm going to talk upon what are the job opportunities for mechanical engineering in different domains. So as Ms. Anukrupa has already introduced, myself Anand Badger, working as assistant professor in the Anand Sahar College of Engineering in Mechanical Engineering Department. So I'd like to start with basically 3 to 4 domains. So firstly, taking with respect to the Make in India concept. So we have seen that our government has launched this concept, and the idea is to bring more in-house job opportunities within India. That is the main concept and agenda behind this. And once this program started, so many of the MNCs, the what we call it as business drivers, came into India, bringing their own technologies and products. So to just name few of them, as you can see, Kia Motors, Tesla, Apple. As Kia, you can see it has just come into the market in just a very short time. It has made itself a top 5 ranking automobile sector in India. We also have Tesla, who have brought in a huge amount of market into India where they can provide job opportunities. Apple is shortly going to start its manufacturing plant for its cell phone within India. Not only the MNC companies, we have our own companies, Indian companies, who are basically, to name just few here, I have taken Mahindra Electrical, Tata Motors, Jindal Steels. These are just the few Indian companies which are trying to provide more and more job opportunities. As in the QA session, I was just looking that a few of the students were asking that the posts or what are the call fors we are looking for mechanical engineers are very less. The thing is, true fact is that there are very much more postings and a lot of advertisements out there. Only thing is we don't know how to search them, where to look for them exactly. So that is the problem, because of which we are feeling that there are less job opportunities. Now, when I talk about to getting placed into these MNCs or Indian companies, what are the key qualities we require to get into it? That is very important. At the end of the day, if any recruiter wants to recruit a mechanical graduate, you look into few of the qualities, like do you have a leadership qualities? Technical is, of course, it's a must. Apart from your technical skills, the leadership qualities also come into the act. So it becomes a time for us to develop the skills, the non-technical skills, I would say, which are very much required in to get a job opportunities over here. So institutions should must come up with different activities where they can develop these qualities and try to make them entrepreneurs too. So at our institutions, we have IDC cell, that is Innovation and Entrepreneur Development Cell, then CIL, Center for Innovation and Leadership. So these cells basically train the students to develop the leadership qualities, make them motivators, ask them or skill them up how to be a team player and how to be an individual player. So these are a few of the qualities that we should develop throughout our course before we look into getting into these big companies. Apart from this, there is one more domain, I think, which is very least explored by most of us. That is government sectors and R&D development centers. So few of the names I have popped up on the screen, very well known: ISRO, DRDO, NIL, BARC, HAL, the pride of our countries, I would say. So ISRO, very well known to all of us, right? So even recently, the government has announced that ISRO is going to open up for the world market, wherein we are trying to produce satellites for other countries and send them out. So DRDO for Defense Research Organization, and BARC and HAL. So what I would suggest is these sectors have a lot of R&D activities which are going across, each and every domain. So for to get into these sectors, we need to have a habit of research and development activities. So basically for this, you need to look into your interest areas, like what actually you are interested into. So if I talk about DRDO, it is all about defense equipments. So we do require our interest into that so we can get into that particular domain. Now, to help us the students to get into these particular domains, we have to involve the students into R&D activities at their undergraduate level itself. because we have to give them a hands-on experience so that they can get an interest into that and they can get placed into these sectors. So at the department level, we have many funded projects going on. So wherein we try to take the students with us and work into those funded projects and just give them a idea about and experience about these R&D developments. Also, we try to take more of the invited talks, guest lectures, so that students can highly interact with them and also they get the experience about it. Now, these uh, government organizations, what I have shown on the screen, you can just go to their websites. They have the career opportunity section over there. You can just keep searching them, because just to give a small example, ISRO almost every year they call for mechanical engineers. You can look into any of the newspaper and magazines. They do require mechanical engineers. The specialization may be in thermal design or manufacturing, but there it comes. BARC, Baba Atomic Research Center. If I'm not wrong, this year itself, BARC has called twice for the recruitment of mechanical engineers, and I think last week itself they had called for or noticed for this. So only thing is we just need to open up our minds and look into the different fields where we can get these job opportunities, and I would say that these are the best places where you can do your research activities and also get a secure job. It's a government job. Apart from these, what are the different career paths that we can look into? As Dr. Dinkaran has already stated that we have three verticals: design, manufacturing, and thermal, and he talked on the robotics. Apart from that, I will just like to go a little bit deeper into this. So when I say career pathways, right, so I just have this interesting clip. Basically, we say design, production, and thermal. So if I take all these topics one by one, as a design engineer, so we all know, we saw it in the introduction video. If you want to design an Iron Man suit, it's not that easy or menial task. So for this, you should have the knowledge of CAD, CAE. You should have how to do the structural engineering, the design engineering. These all knowledge should be there. So if your interest is totally driving towards this domain, yes, you can be completing your mechanical engineering. Take a master's in machine design, then definitely you can get into design sectors. Production sector, lot of job opportunities, as once again I said, with the MNCs coming into India, and Bangalore itself is called as the hub for startups, right? So here you can get hell lot of production companies where you can definitely get the job opportunities. And I saw in the QA session that if I want to do my MBA courses, management courses after my mechanical engineering, yes, you can definitely do that, because if you just look an average way, most of the managers in the companies are mechanical engineers because of their competency and the skills what they have. So you can just see in the job roles: production engineer, fabrication engineer, drilling engineer, and there is one thing called as operation management, where the management guys, MBA guys, are most recruited. Apart from that, you have sales and other job responses. If you take into the medical equipments, health environment, the sales engineers are very much required there. And also you require to have the knowledge of simulation. Under maintenance tasks, you have different roles with power engineering and control systems and engineering. And under planning, obviously you need to have the project management skills and the logistic engineers too. So if I want to put up in one single image, so that is right on the screen, mechanical engineer in the core, and these all are the industries where you can get into or get placed into. So this is just, I'm giving a broad picture, starting from the food and beverages, what we call it as the packing industry, chemical industries, we have specialty chemicals. Nowadays, if you believe it or not, even our textile industries are coming with antibacterial thing, right? So that is the chemical industry. To make these machines, we do require them. Automotive, very wide sector. Within automotive, electric vehicles is the latest trending technology what is going on. Power and energy industry, the powers, coals, wind energies, steel industry, cement, metallurgical, consumer goods, pharmaceutical, textiles, glass industry. So you look into any industry, you name them, you do have one place for there. Only thing is you need to set your mind that what way you want to go, and depending upon them, you need to choose your proper career. So some more scopes when coming to the biggest trend, what is going on now, and most of the QA questions I saw, most of you are asking, as a mechanical engineer, can I get into IT sector? Can I get into IT jobs? Yes, definitely. Nowadays, the trend is not pure mechanical, it is all integrated. Many departments coming together and integrating and making the job, but core essence still lies over here. So just to show you a glimpse, so if you do core mechanical engineering, you can go into digital manufacturing. So digital manufacturing, one of the biggest area, example 3D printings, we have CNC machines, we have automated manufacturing units, wherein into, as Dr. Dinakaran said, industry 4.0 revolution, where we have completely automation of the manufacturing industries. Then we have industrial automations, AI and ML, artificial intelligence and machine learning. Whatever work the machine used to do manually, now it is just automated through set of programs and codes. And at the end of the day, it's against the machines which are working. Only thing is you require a little knowledge about coding. Data science, one more very important domain, and robotics, as sir has already taken part upon that. Now, to make sure that mechanical engineers get into this field, I would insist on this thing that as a mechanical engineer, it has become a mandatory for us to learn and know at least one coding language. That has become the need for the time. So at our institution, we have already started Python, Java, and machine learning for mechanical engineers. So our department has adopted this, and we are giving a specialized course in Java, applications of Python and machine learning, so that our students are well equipped and be industry ready once they are graduated. So this has to come into consideration. And once you are aware of these job sections, then these are all the job profiles which will shoot you: a data scientist, a big data engineer, blockchain engineer, cloud architect, AI engineer, product management, full stack development, software architecture, IoT solution. These all sectors will require mechanical engineers. If you just have a little knowledge of coding, that would do. You can just take out any one, and definitely you can look for your job opportunities in IT sectors also. Apart from all of this, one more big sector which I have left here is the renewable sources sector. So many of the industries, for if I want to name the Schneider Electrical, GM, Mercedes-Benz, Daimler, they all are now moving slowly towards the renewable side. So even their side also we have a very huge scope. So this was just a brief glimpse for where you can look for your job opportunities. So that's from my side. Thank you, Ms. Sanukrupa. So any questions based on this, you can definitely post it, and I'll definitely answer them.
Sure. Thank you, sir, for talking about, I think, job opportunities across all the sectors. I think one of the questions that has come up in the chat is about further studies after doing mechanical engineering, right? Whether it's doing masters, doing maybe even research, getting into that. Could you maybe talk a little bit about, okay, somebody has finished their BTech or their BE, and they're considering their masters. What do they need to think about? What are their considerations? What are their options in India, abroad? If you could talk a little bit about that.
Yeah. So when you talk about higher studies, definitely we do have many more domains into it. So once you complete your mechanical engineering as a core, you can definitely look into mechatronics as one of the part. You can definitely look into data science for your higher studies. You can also look into advanced manufacturing process. So there is a stream specialized for that also. If you are interested into management side, if you don't want to go into technical, if you want to go into a management side, you can look into quality assurance. That is one more biggest higher studies concept you can go into. You can go into maintenance engineer. So every industry, wherever you work, you do require a maintenance engineer to take care of the entire production capacity. So the aspect is very wide. Only thing is you can even look for your blockchain managements, wherein if I talk about the different methods like agile manufacturing, and we have just-in-time manufacturing. So these all are the concepts which come under the manufacturing sector itself, but we'll have to just take out our interest in which way you want to go. So definitely job opportunities are there inside and outside India also. So you can look into the many verticals of that.
Dr. Hasibuddin, anything to add to that?
I think there are a lot of questions in the chat box. One question is why the pay packages are low for mechanical engineers compared to IT sector. So I think it is just a myth. Though in the last few years, though the IT companies are paying very fat packages, but if you look at top manufacturers across the world, so if you get into any top manufacturing firm, they are paying with par with the IT counterparts. So those who can't get into those type of companies, though there may be a little bit comparatively low packages, but with experience they can. What we have seen, our students are doing very well after putting 4 or 5 years of experience. They are getting, if not with par with the IT counterparts, maybe somewhere close to it. So it is just a myth. And one more question, what I see is, is there any scope for mechanical engineering government jobs? Yeah, definitely. If we look at the core sector, that is the government job sector, what they ask for this the core branches: electrical engineering, mechanical engineering. This is what I think Anand Badikar has already thrown on the mechanical domains where they are recruiting mechanical engineers. So you take at any core, that is R&D organization, HAL, NAL, ISRO, there is definitely a lot of scope for mechanical engineering.
Yeah, I think the point that is coming across very clearly is that everything is about being well-rounded, interdisciplinary, right? You can keep mechanical engineering as your core, but the industries have evolved that the more other skills you pick up, if you pick up entrepreneurial skills, business development skills, then the scope just widens up a lot. I think another question was, we talked about so many options, so many different pathways you can go down as a mechanical engineer. The choices are all out there. How can someone make a choice as a fresher when they're thinking about, okay, what to explore? How do they make that choice? Maybe you can talk about how you made your choice. Maybe Dr. Dinakaran, you can talk about how did you make that choice that, okay, this is what I'm interested in, because there's just so many different options. Maybe that will help the person who is asking the question.
See, the first thing is, what is our interest? Suppose if I like to go for some engineering program, what is my interest? For which we should give high priority. All other things are secondary. Because each and every branch of engineering has its own uniqueness, own opportunities. So if any student would like to explore the engineering as their option, first they have to keep in their minds about their interest level. That is one. Number two, they have to see what are the opportunities outside. So as Dr. Anand mentioned, renewable energy is the future. So which department is focusing on that? Which program will focus more on that? If they see that, they come to know what are the opportunities in the future, because immediately they are not going to get the opportunity in the industry. After 4 years only, they are going to go. So they can see what are the domains which are coming up. Maybe in near future, what are the domains are going to dominate the market. So whether we are orienting towards that or not, that matters. So that we can see through the studies or through surveys and through magazines, through discussion with the experts and professors, they can come to know what are the domains that are opening up new opportunities in near future. That is number two. Then number three, whether the domain that is selected for me is suitable or not. Suppose many of them are asking about the mechatronics or mechanical or some other branch. How do we go about? Say if we take a mechatronics engineering, it's more about doing and learning. Okay, they will be fabricating many of the products, automated systems, robots, and they will learn. So if somebody is having inclination towards such kind of activities, they would have gone for some of the exhibitions in their school days. They have participated in many of the science competitions. If they have such kind of inclinations, doing by learning, they can go for such courses like mechatronics. Okay, so similarly, if they are interested in coding, Okay, they are very much interested in coding and programming. They can go for IT or a CSE department because they have some inbuilt talent that they could do well in coding and programming. So this is how they can identify themselves. What are the key strength for them? Accordingly, they can select the departments. So their interest level, then the opportunities they have to see, then they have to check whether we have the talents or whether do we have an interest to develop those things with us. It is not necessary that they should have a talent now itself. They should have those skills now itself. If they have inclination or interest to learn, willingness to learn those things, definitely they can take a step to move into the mechanical engineering or any other department. So mechanical engineering, if you take all three of the speakers we have mentioned, what are the different opportunities? Because it's mother of engineering, the opportunity is very wide. So in the near future, there will be opportunities in the renewable sector, then EV vehicles, then the spacecraft, all those things. Aeronautical field is now picking up. Dr. Anand mentioned about ISRO and all. So for which the basic qualification is mechanical engineering. After that, they can move to the aeronautical engineering, or they can move to the automobile engineering, or they can move to the process engineering or management. So much of opportunities are there for them. Yeah, this is how they have to select.
Thank you, sir. That was helpful. I'll bring up another interesting question. I think it's come up a few times. I'll open it up to the panel. There is an anxiety that because of automation, because of artificial intelligence, that the jobs of mechanical engineers will get replaced. We will not be necessary anymore. Our jobs will be replaced by automation, things like that. Would anybody in the panel like to add? Yeah, go ahead.
Yeah, I will add that.
Yeah.
Since I'm working in the automation and robotics, I could answer for that. See, the International Federation of Robotics, that's the international organization, they have published many of the surveys based on the discussions we are making now. So it deals with how many robots are built, how many robots are utilized by the industries in the specific countries. Say in Germany, they took that study, okay, in US and in China, in Brazil, and many of the countries, how many robots they are adapting in the industries, and what is the fluctuations in the employment. They have mapped both the things. They found that the trend is different in different countries. Suppose if you take Germany, there is no correlation between the number of robots and the employment. Sometimes it goes up, goes down, irrespective of the robots adapted, the opportunities are going up or going down. So if you see India, suppose in the Indian scenario, what is the thing we have to notice? Normally, the MNCs, the corporate industries, they go for automation. When they are going for automation, big industries, mass production, when they are going for automation, it's newly opening up the avenues like robotics, automation systems, all other things. Actually, it is opening up new because that is not there. Suppose in the developed countries, say if you take USA, the trend is different in US. Because of the automation and robotics, it gives them advantage for developing countries, particularly in India. It opens a new avenues for robotics engineers, automation engineers to build the industries, new industries or new systems. That is one. Number two, developing the existing system and customizing it for our country requirements. It is not that whatever is available in the US, just we can take it and adapt it. Because the cost of car that is used in the US and the cost that we use in India, it's totally different. The road conditions are different. Climatic conditions are different. Norms are different. So whatever maybe the product that is coming globally, directly we cannot just take it and fit it to our country. Some customization is required because some indigenous systems are required for suiting them to our requirements. So developing such systems in India, that itself is opening up many of the opportunities for us. Though those things are already available, customizing and indigenously developing those systems for India opens up many of the opportunities for us. So the answer is automation and robotics technologies implemented in the industries are increasing the employment. It is not stopping the youngsters to coming in. Yeah.
Even for the components or parts that are required for automation has to be manufactured by mechanical engineers. So
yeah.
So
automation is
opening other avenues.
Yeah.
Yeah, thank you. Yeah, I think it is, it's just understanding really where mechanical engineering's place is in the world. It's like you said, sir, the parts required for automation, the back end of automation and AI still has to be a human being, and that still needs a mechanical engineer. It's just that the industry is changing. That's the thing. It's not dwindling, it's not disappearing. It's changing seems to be the biggest takeaway. We'll just take one last question. Maybe Professor Hazibuddin or Professor Anand, you can answer this. Outside of the classroom, right? I'm part of an engineering course. I picked the course. I have great courses. Outside of the classroom, what are some things I can do to increase my scope or my job prospects in both job industry and also to just be a truly great mechanical engineer? What are things that students or even postgraduate students, people who are in the job industry, what are the things they can do proactively to keep upskilling themselves? Any thoughts on that?
Right. I would like to just answer this question initially, and maybe later Dr. Hasibuddin can add few points to it. So very first thing is, apart from your curriculum, the very important need is to develop your skills, and one of the way to do is through internships. So you can try to get as many as internships possible into different companies and sectors, so that you can be well aware about the well-versed things what are going into those companies. So one thing is about internship opportunities that you can take up, and nowadays internship has become a very much mandatory thing, because we say that our students are lagging a little bit of skills, because we usually say that they are not industry ready. So first thing that can be gapped is through the internships. Second thing, apart from whatever you study, there are some add-on courses required which you can get it done through online. For example, many of the students are asking that as a mechanical engineer, one interesting question was there with respect to CAD CAM. So the attendee was asking that what is the future for CAD CAM only in mechanical engineering and even for simulation. Now, whatever sector you go into, whether it may be healthcare, whether it may be production, whether it may be packing industry, renewable, wherever you go, you definitely do require some equipments over there to work. And the trend is that we have to invest less money, less time, and still the product should be working. So for that, only answer is virtual analysis or virtual simulation. So when we talk about virtual simulation, we do require the drawings, which is the blueprint for anything. We do require the simulation for these products, whether you take into robotics, even if you want to do a robotic arm, if you want to study the kinematics and dynamics of it, you cannot directly just manufacture it, put it, program, and check. Before that, you have to make sure that you have to simulate them virtually, ensure that it is working properly, and only then you can take into the reality. So these virtual tools, whatever we are having nowadays, are very much helpful, and this is never going to die out or wear out, because at the end of the day, when we require a finished finalized product, it should save us the cost and time both. So I think the second point is you should take up few of the virtual tools or softwares which are available online, even at free of cost and even at a very minimal cost. And even you can get through them NPTEL courses and MOOCs courses, which government of India is giving at free of cost. You can take those courses and do it. So I'd like to say these are few of the things outside your curriculum you can do. And I think Dr. Hasibuddin can add few more points to it.
To add to this, nowadays most of the universities have added project at every level, first year onwards. So even if the curriculum has no scope for that type of projects, students can take up mini projects that are linked with the course, and that's what we are doing at our institution. So a small module is given to a group of students, 4 or 5. They can work on it. They can write a research paper on it, because those students who are eyeing top universities abroad for higher studies, there is a lot of weightage given for research publications. So publications in journals and attending conferences, this is what that is required apart from the academics. So nowadays, those days are gone where the candidates were recruited based on the percentage what they score in the university. So they need overall, the employees look for overall ability, right from teammanship, how they work in teams, their presentation skills, communications, everything is very important. So working on research projects, mini projects, and publishing papers and attending conferences, all these are add-ons that will go into their resume when they are facing interviews, campus interviews. These are definitely going to help the students.
Thank you, sir. Thank you so much, panelists. This was really helpful, and thank you for shedding the light and I think busting a lot of myths about mechanical engineering that are very easy to believe. So that was really insightful. I'd just like to close the session off talking about somebody. We all know Elon Musk. We know the stories. It's nice to listen to stories about him in the news and all of that. But SpaceX is one of Elon Musk's companies. He's the CEO, he's the founder. But I just want us to think a little bit about the COO of SpaceX, is a woman called Gwynne Shotwell. She's the president and COO of SpaceX, which is Elon Musk's space exploration company, right? Just a quick, interesting fact about her. When she was in high school, she was a really good athlete. She was into cheerleading. She was a great athlete. She thought she was in the varsity basketball team. She thought that was her future. When she was in high school, she actually attended a panel discussion about engineering in her hometown. And they talked about mechanical engineering. Must have been very similar to what we spent the last hour doing. And at the end of that panel discussion, she decided that she would apply to be an engineer. And she did her course in mechanical engineering, of course, grew, and now she handles the operations for a company as big as SpaceX. So just think about that, everyone who is here in the session. If there's something from this panel discussion that can inspire you or even just reignite a love for mechanical engineering in you, there is no end to the scope for mechanical engineering in the digital era. I think that's very clearly established today. And I'd like to share a quote that Gwynne Shotwell actually says. She says, the key to join an industry is that you have passion for it. If you love cars, then automotive is where you should end up. I'll repeat that. The key to join an industry is that you should have passion for it. So if you have passion for robots, if you have passion even for Iron Man, if there's something about watching Iron Man do what he does in movies inspires you, then mechanical engineering might be the way for you to go. And the opportunities are just endless. Thank you so much. Thank you so much to the Hindu and the Dayananda Sagar institutions for putting this webinar up. Thank you so much to our panelists and audience. Thank you for being here. Have a great day.
Thank you.
Thank you.
And also I thank the organizers for giving us an opportunity.